चलो डिस्कस करता हूँ सर। हेलो कौशल सर, चलो डिस्कस करता हूँ।
हाँ खुश रहो भाई। ब्रेश क्या हाल है?
बढ़िया हूँ सर।
चलो कुछ सुना भी करो, कुछ जो है लेक्चर में कुछ क्वेश्चन वगैरह भी पूछा करो, इंटरेक्टिव हो इससे सेशन।
वैसे सर टोटल सुनता तो हूँ लेकिन मैं पूछता नहीं हूँ, लेकिन मैं सुनता टोटली हूँ।
क्वेश्चन भी पूछना चाहिए।
अच्छा अच्छा, मुझे लगता भी बहुत अच्छा है सर।
हाँ चलो बढ़िया है, थैंक यू।
धीमे धीमे आप लोगों में मैं भी आके सीख रहा हूँ।
अरे जो है फिर से ठीक है।
Hello, good afternoon, everyone.
Yes, Nasir. Can you hear me?
Yes, sir. I can. Yes, sir.
Okay.
Your video is not on, sir.
Video not on. Video is already on. ओके, फिर से हम ट्राई कर रहे हैं, वेट करना थोड़ा सा।
Okay, sir. Okay.
No, no.
Yes, sir.
No,
Yes,
no.
sir. Sir, we can see you. नमस्कार सर.
और सुनो.
जी सर. बढ़िया सर. बढ़िया सर.
आवाज क्लियर नहीं आ रही.
There is just disturbance in the voice, sir. It is okay now. Okay.
वो क्योंकि अगर 2-3 माइक चालू हो तब.
Please, all the participants, please put your mic on mute. Everyone, please keep mute. Okay, okay. Now your mic Now your mic is mute, sir. Okay.
तो एक बार प्रेजेंटेशन चालू हो जाए तो केवल हमारा माइक चालू रहेगा, बाकी सबके बंद हो जाएगा.
ठीक है सर, एक बार ट्राई करके रन करके देख लीजिए पीपीटी में.
ओके.
लाइव कर दिया है.
स्लाइड दिख रही है.
Yes sir, we can see sir. इसको पीपीटी प्रेजेंटेशन मोड में डाल दीजिए एक बार.
एक मिनट. एक कंप्यूटर हमारा भी स्लो हो गया है.
जी जी जी. कोई नहीं सर, स्लो स्लो ही चलते हैं. Sir, can meanwhile we can just give the formal introduction.
ठीक है स्टार्ट कर दो तो उसको।
Okay sir, okay. Good evening everyone. Welcome back to the third lecture of the 7th day of 21-day training program. Our resource person Dr. Arun Gupta sir has already joined us. So on behalf of the organizing committee and my own behalf, I welcome you sir to the 21-day training program. Just to brief you about the program sir, it is a 21-day training program and total 34 participants are attending this program. All are the assistant professors in different universities of India. Sir,
Sir, it's working completely fine, sir. Perfect.
Okay.
Yeah, please carry on, sir.
At the same time, sir, let me have this opportunity to introduce you as well to the participant. Dr. Arbind Gupta sir is a professor in Faculty of Chemical and Processing Engineering Technology, University Malaysia, Pahang, Gambang, Malaysia. It is a state university, state engineering university there. He is also a director of Center for Biocomposite and Innovation Material. He has done his graduation in forestry from JNKV Jabalpur. He was the gold medalist of his batch. He did his MSc in Wood Science and Technology from FRI Dehradun and PhD in composite wood from University of Canterbury, Christchurch, New Zealand. So far, he has supervised 4 PhD students, several master students, and I'm a proud one who got chance to work under his supervision. He is my supervisor of PhD supervisor. He has received more than 20 golds in various conferences and exhibitions. Actually, we usually say about him that whenever he goes to any exhibition, he brings the gold. He is, he is almost certain if he will go to the, he will participate in the exhibition, he will bring the gold. That is for sure. He has handled more than 15 university projects as well as industrial projects. He is a consultant to many wood industries in nearby of the Gambang, like in Timarlo and Gambang industrial area. He is giving his consultancy services to many industries. He has published more than 70 research papers and attended more than 30 conference papers, published more than 30 conference papers, and he has one book on his name. He has 2 US patents. He has 7 Malaysian granted patents. He has 9 applied patents, and he has one of the patent on keratin. His one patent, keratin from chicken, has been commercialized, and now he is commercially producing the protein from chicken feather. And not only commercialized, but he has started the industrial production of this protein, and from that protein they are making anti-aging cream. So it is a kind of, means he is getting so much popularity not only in the Malaysia, but he is supplying this product now to India also. He is having collaboration with the Indian universities. So he is having a great potential of patent, doing real research. He is doing a real research, doing patents and so many things. So with this brief introduction, I would request Arun sir to please start your presentation. Over to you, sir.
Okay, thank you very much, Nasir. All right, so I think I will start, and if there is any difficulty, because we are sitting in 2 different countries, so if there is any difficulty in the voice or anything, you can send the message or let me know, because otherwise I will not know that what are the things from this side. Okay, and another thing is participants are mainly the lecturers or students or
Yes,
lecturers
sir.
from different universities?
They are only lecturers, sir. They are either assistant professor or scientist. So they are equivalent to assistant professor.
Okay, mainly from forestry agriculture line or different line?
All are from forestry background, sir. Mostly.
All right. Yes, because I need to know that, okay, that what I have to explain and how much we can touch in this point. Okay, so I think as Nasir already mentioned, that Nasir is one of my second student of the PhD. When after completing my PhD from New Zealand, I joined University Malaysia Pahang, and then Nasir and Anuj were the first one who have done his PhD. So I'm quite happy that they have progressed quite well in their profession. And while doing their PhD, they have developed a new product like a biocomposite and other things. Okay, so in the field of wood composite, mainly we call it biocomposite because like MDF, particle board, and then the this one, and then the chipboard all comes under the biocomposite. So there are two main areas in which I was working. One was to add because suppose if we consider the present wood composite, and we all know that wood composite is a bad conductor of heat. And whenever we want to use it in for the bookshelf or any other places, then the strength is also not there. So the one area which I have worked is to add high conductive nanoparticles like aluminum oxide, carbon nanotubes, and carbon fibers to increase the strength. So I will try to cover this project. And then there are other projects like the bioadhesive and other things, so which I will try to see that within that time I can cover. Otherwise, I will provide my email ID and other contact address. So if somebody want to know more about the project, then they can email to me, or so that I can provide the research papers and these things. Okay. So the first topic that I want to cover is the nanowood composite. Nanowood composite, the means when we are adding the high conductive nanoparticles into the wood fibers and to increase the strength. So now, means earlier when I joined in 2010, like carbon nanotubes and other things were used in the mechanical engineering or different nanocomposite like the wood plastic composite and other things. But till that time, nobody have used these particles into the wood fibers or to make the MDF. So we have tried to do some experiment on it, and I will show you the result that we got. And as Nasir have mentioned that I'm working here, I got a MOU and collaboration with some of the big industries here like Robin MDF, Miko Chipboard, and we are doing the research with them. So whatever things we are developing in our lab, we are also conducting the trial into the plant, and we'll see and we'll try to get the feedback from them and then keep on improving the product. Okay, so basically this presentation will cover the introduction, what is the problem, existing problem, and then we have used different grades of nanoparticles like aluminum oxide, carbon nanotubes, carbon fibers into the wood fibers, and then we have compared the result also. And then the experiment result and things I will cover in my presentation. Okay, because I'm working in Malaysia, so I have to. Okay, so this one is like a brief summary of industries in Malaysia. Malaysia is one of the top producer of wood composite, and they are exporting even to India also. There you can find the Malaysian timber, and a lot of industries are importing the wood fibers and even the complete one also. Earlier, the Century Ply, which is in Calcutta, they used to import the MDF board from Malaysia, and then they put the brand name of Century, and then they used to sell it. So Malaysia is quite good in the wood industry area. There are 11 MDF and 11 particle plants, and quite a number of plywood mills. And if we consider the economy-wise, that wood industry plays quite a major role in Malaysia. They are fourth biggest industrial sector of Malaysian economy. So if we consider in India, then there are MDF plant. I think I have heard that there are a lot of new MDF plant also from the earlier.
The recording has stopped.
Earlier there were this one, Manglam Timber. My first job, I have completed my master's in from Dehradun, wood science and technology. And after that, I joined the Manglam Timber, which is in Odisha. It is a MDF plant. And at that time was only 2-3. But what I have heard is there is a Action Su company. They are having the MDF plant, and then the Century Plywood is also having the MDF plant in Punjab area. So there are now quite a lot of MDF companies all around India. Okay, this one is slightly miss in Malaysia. If we compare them, there are, as I mentioned, that there are 11 MDF plant, and then the production capacity is 4,200. So each MDF plant is having a 300, 470 hours, near about this kind of the production facilities. We are working with this one, Robin MDF, which is in Mantikau. So we are having a collaboration with the Robin MDF, and then we are also having collaboration with the Sigamat panel board. And these are the two MDF plant, and then there is a Miko chip board, which is near, which is not far from our university. So we are also having the collaboration with them. I think one area where is this general thing that in India, suppose all the research institute need to
This meeting is being recorded.
Collaborate with the industry. That is a good thing, because suppose we are doing the research and when we are not doing the trials in the industry, then we don't know whether that product will be successful or not. So it is always good to collaborate with the industry, try to conduct, take the problems from the industry and then try to develop the products. Okay, so the main problem that we have taken this project is the one is the low thermal conductivity of wood fiber. So as we know that wood fibers are having low thermal conductivity, and to make the wood composite, or what we need to do is we take the logs from the forest, we convert these logs into the wood fibers, then we spray the adhesive over it and then do the hot pressing. So hot pressing is one of the main thing. And then when we do the hot pressing and we know that wood fibers are having the low thermal conductivity, it takes a lot of time. Suppose if we say we are going to make a wood composite and we want to make a thick board like 16 mm or 18 mm board, then if we have to make the hot pressing, it can take maybe 10 or 12 or 15 minutes. Suppose it takes 10 minutes, then in 1 hour we can take only 6 batch. So only 6 batch of the MDF we can take out. So this will reduce the production capacity of the plant. So that is one area that, okay, because wood fibers, we all know that it is low thermal conductivity. And for our project, we want to add like the aluminum oxide or carbon nanotubes that can also increase the heat conductivity and will also improve the strength of the board. So suppose at present when we are using completely wood fibers, and then when we give the load, if we are making a book shelf or something, then we see that if we put too much load, then the warping will be there into the wood composite. So these things we try to solve it. Then another area is we have also found that when we add the carbon nanotubes and different nanomaterials, it will also decrease the formaldehyde emission from the wood board. Worldwide, suppose all the wood composite industry, whether it is particle board or plywood, they are using mainly two resin, urea formaldehyde and phenol formaldehyde. And both this adhesive will emit the formaldehyde emission. And as we know that excess exposure to formaldehyde can cause cancer. It is already a lot of research is done in the US, and it was found that if there is an excess emission or excess exposure to the formaldehyde emission, then it can cause cancer. So now all the developed countries, whether it is US, Europe, Japan, all the countries are putting like a ban that they don't want to import the wood composite with a higher formaldehyde emission. So this one is another area, because when I joined here in Malaysia, we visited the companies and we find out, okay, what are the problems they're facing. So one is like the low bending strength or low strength. Another is the formaldehyde emission. So from there we have taken the project and then we start developing the things to solve it. Okay, so this one is, we call it as a nanowood composite. It is also, we had applied for a US patent on this. We got the US patent granted, Malaysian patent granted on our technology, what we have developed here. So the main idea of this project was to add the high conductive nanoparticles into the wood fibers. And then we have conducted the research to find out that how much amount and what kind of things we need to do it to improve the strength, and we have analyzed the whole thing. And we have also found that when we add this one nanoparticles into the wood fibers, then it will increase the strength plus also lower the formaldehyde emission. Okay, there are a few other reasons for using the nanoparticles into the wood fibers. One is, suppose when we use the nanoparticle, then even a small amount of nanoparticle can spread around. Like the one main which we got success is the multi-walled carbon nanotubes.
Okay. Hello. Sir, I can't hear you. Hello everyone. I think there is a technical problem with the resource person side. So just wait for a minute. He's trying to reconnect.
कनेक्ट हो गया कि
Yes, sir. Welcome back, sir. Yes, you are connected now, sir. I can hear you.
So, okay. So until what slide you have seen, Miss?
Run your slide first. I will see.
Okay, I will. Okay, wait.
दो.
Okay, so like how many slides I have covered previous with the before
I
disconnection?
think it has been covered. Yes. It has already been covered, sir. Yes.
Advantages.
No, before this, sir. Back slide.
Problem statement covered.
Yes, problem. We were on problem statement, sir.
Okay, problem statement. All right.
Yes.
So I can start from here.
Yes, sir.
Okay. All right. So I think is good. Means if any problem, Nasir, you send me the message in the
Sure,
WhatsApp,
sir.
so
Sure, sir.
I can.
Sure.
Okay. All right. So in problem this one, because suppose all the projects we are working on to solve the problems of the industry. So as I mentioned that wood is a very bad conductor of heat, and then when we are doing the hot pressing, it takes a lot of time. Whenever we are making a thick board like 12 or 16 or 18 mm, it can take 10 minutes or 15 minutes. So in 1 hour, suppose if it takes 10 minutes, then in 1 hour we can make only 6 batches. So the production capacity of the plant will go down. And at the same time, we know that the wood fibers are not that much strong. So if we are using this composite in making the cell, and if we put too much load, then it will warp. So this thing is there. Plus another is the formaldehyde emission. So as we know that all the countries around the world, they have put the ban on the wood composite that is having the higher formaldehyde emission. Like we know that the two main resin that all the companies are using is urea formaldehyde and phenol formaldehyde. And on all these composite, because if we make a furniture and all these things, and all this wood composite will emit the formaldehyde, and it was found by the US have done the research, and it was found that too much exposure to the formaldehyde emission can cause cancer. So these are the main problems. Okay, so we have used the nanoparticles, aluminum oxide and carbon nanotubes into the wood composite, and to increase the conductivity of the heat. Before starting the research we have done, the simulation, we have computer simulation model in which we can put the parameters like the hot pressing time and all other details. It works like a virtual press. It is what we can see is, suppose rather than conducting the experiment in the lab, you can put the values into the computer. It is a software in which you can put, okay, how much amount of the wood fibers, initial moisture content, hot pressing temperature, and all these values. And then you run the simulation, and the simulation will generate the result that, okay, what kind of the properties will come out. So it is like you don't need to go into the lab, you can just put the values and can see. And these kind of simulation software are used when we want to develop some new kind of a composite. Rather than doing a lot of trial and error, we can run on the computer. Okay, so the main advantages of nanoparticles is it provide more surface area because it is in the nano size. You need to use only a very small amount of nanoparticles. It can spread easily all around the wood composite. And when somebody want to cut the wood composite into the different size or anything, it will not create any problem while cutting or molding the this one composite. And we, as I mentioned, that I will also cover in our results that we have tried both metal oxide like silver oxide and aluminum oxide, plus the carbon nanotubes, plus the carbon fibers also. Okay, so as seen in this picture, that wood composite is a panel prepared by wood fibers, and then in this one we use the nanoparticles and resin. And it will the application of the wood composite or the nano wood composite is the same place as our normal furniture. It can be used on all our same places. The only difference is that we are using the high conductive nanoparticles, and it is having the higher strength as comparison to the other wood composite. Okay, this one is a process to make the MDF or particle board, more or less same process. So from the beginning, you can see that we take the logs from the forest, and then we remove the outer, because bark we don't want into the wood fiber, so we remove the bark, then convert into the small chips, and these then screening, because suppose when the logs are coming from the forest, then it will have the sand or other particles which we don't want in the composite. So there is a screening, and then these chips will go into the refiner. In the refiner, these wood chips will be converted into the small fibers like our hair. So in MDF, we are using the fibers, and fibers is like our hair, very thin. So the refiner will it is at a very high temperature, so these chips will be broken into the small pieces, and then there is this one that it will convert into the small fibers. Then after that is a drying, and after that it will do the bed formation. So all these fibers will form the layer like a thick layer, loose bed, and then it will go into the press. So these wood fibers bed will go inside the press, and then it will convert into the this one composer, this MDF. There is a sewing machine, so 8 by 4 feet sheet will be formed. The plant and this one, the Banglam timber, which belongs to the Birla group in Odisha, they are having more or less same line, but the press is not the continuous one because it was old plant, so it is having the batch press. What is okay? So this one is showing that whenever we are doing the hot pressing, it takes suppose both the plates are at 180-degree temperature, and then when we press the wood fibers, then because wood itself is a bad conductor of heat, it takes a lot of time, and if we don't press it properly, then what happens is, suppose we have added the resin like urea formaldehyde, we have added it to the wood composite. Then in the center, the resin will not be cured. To cure the resin, we need to keep the resin at more than 100 degrees Celsius temperature for a few minutes, then only it will harden. So we know that suppose when we buy the urea formaldehyde, it is in a liquid form. And we need to give the temperature to make it hard or solidified. So whenever we are doing the hot pressing, and then if the temperature do not reach into the center, the resin at the center will not become solidified, and the board will not be formed. And board can easily break into the two pieces. These are actually the real problems that companies like MDF or particle board companies are facing. Ideally, the temperature from the top and bottom, like in another picture, need to come, and then the temperature need to uniformly distribute so that all the resin can be cured. So one way is we heat it for a longer time. Another is when we mix the high conductive nanoparticles, it will increase the conductivity, and then the heat can be transferred much faster. So here in this picture, you can see one is a press. So bench press is the suppose where is the old technology, and the Birla plant in sorry, Odisha is using the batch press. But the newer plant, I think maybe the new plant which is by the Century and other company will have the continuous press. So basically, our aim was to increase the heat transfer so the board can become much better. Okay, so we have conducted the research in our lab. We have formed the board. We have taken the wood fibers from the nearby this one MDF plant, and the initial moisture content is 6.8. The solid content was 0.64. And dimension of the board is 20 by 20 centimeter, and we were targeting the density of 750. So these are the parameters that we have put for our experiments, and then we have maintained the plating temperature 180 degrees. Okay, just 1 minute. Okay, so on the one side is you can see that this one is a instrument where we were mixing the wood fibers with the adhesive, and we have mixed the nanoparticles into the adhesive, and then we spray onto the wood fibers. Then we have formed the mat, and then we use the hot press in our lab to make the this one wood composite or nano wood composite. Okay, now how we are going to test that it will improve the heat conductivity. So what we have done is we have put the thermocouple wire. Thermocouple wire can give the temperature. So thermocouple, suppose we have put the thermocouple wire into the center of the board, and then we have conducted the hot pressing. So center of the board will tell means how much time it takes to reach the temperature. So from the figure you can see that SB, this one is a standard board without the nanoparticles, and if we are CNT is a carbon nanotubes. So we have added carbon nanotubes 1% and 2%, and if we mix the carbon nanotubes, so from this figure you can see that after how much 250 seconds, the if the board is having the carbon nanotubes, then the temperature in the center will rise faster. So that is the aim of what we want to achieve into this project, because we want to add the nanoparticles and we want to increase the transfer of the heat. So here you can see that when we mix the carbon nanotubes at a different percentage, then it will increase faster. Okay, this one is a TGA, and TGA is suppose we heat the samples at a very high temperature, and then we see that at means 400 how much is the material left. So these are the figures which is showing that more or less same trend. Okay, sorry. So we have also taken the picture SEM analysis when we want like a higher magnification, like 700 times. Then we have taken the picture, and then you can see small white this one particles onto the wood fiber. These are the nanoparticles onto the wood fibers. Okay, so these are sample pictures from our different experiments. Okay, this is a same picture of the multi-walled carbon nanotubes. Sorry. Actually, there are two types of carbon nanotubes. One is called single-walled carbon nanotubes, which is a single fiber, and another is called a multi-walled carbon nanotube. So we have used the multi-walled carbon nanotubes. It provides higher strength, and it also provides the mechanical, mechanical strength plus higher thermal conductivity. And if we have to, because suppose whenever we are working with the industry, we also need to propose that the solution is can come within their budget. So multi-walled carbon nanotubes can be available in bulk from China. In India, I don't know that whether there are producers, but in China you can buy the multi-walled carbon tube at a cheaper rate, and you can buy in a bulk. Okay, so along with the testing of the wood composite or by the thermal, we have put this one thermocouple. We have also conducted the thermal conductivity test. We have taken the samples of standard board without mixing anything, and then Al is aluminum oxide 1%, CNT is carbon nanotube. So as I mentioned that we have tried different materials, aluminum oxide, silver oxide, carbon nanotubes, and the carbon fiber. So then we also want to know that which one is giving the best result. So from the graph, you can see that carbon nanotubes are giving the higher thermal conductivity in comparison to the standard and in comparison to the aluminum oxide. So then later on we start focusing much on the carbon nanotubes or the carbon fibers. Okay, for the bending strength, because suppose whenever we are making the wood composite and we are going to use it for furniture or making the bookshelf or partition or any other thing, we need to test that, okay, how much is the mechanical strength or the MOR, modulus of rupture. So we have tested our wood composite, which we have prepared in our lab. And then we have seen, as you can see from here, that the standard board is having suppose 32 or 33 megapascal, but if we add carbon nanotube 0.5%, it is reaching above 40, and if it is 1%, then nearly 44. So there is a means if you compare the amount of carbon nanotubes is only 0.5%, very small percentage, but that how it plays an important role into the strength, that how much strength it will increase. So that you can see the 25% increase in the strength of the this one bending strength. Okay, so internal bonding, because these are the two main bonding. So these are the two main testing. So one is the internal bond, where we take the sample and use the universal testing machine to break it. So if we check that the standard without carbon nanotubes is giving 1.0, 1.3, 1.42 megapascal, but with the carbon nanotubes it is giving 1.2 to 1.21. So still the strength is higher. Okay, so as we have seen that we have done this project in 2010, and then we have taken this project to the Malaysian exhibition in Kuala Lumpur, and we got a gold medal for this one, and then we received a gold medal in INPEX research exhibition in the US, and we have filed the Malaysian patent first, and when our Malaysian patent got granted, and then we have also filed the US patent, and both the patent granted. So this means we hold the technology, and if somebody want to use our technology, then they need to do the licensing. They need to pay the licensing and the royalty to the university. So it was an innovative idea that we have used the new kind of the nanoparticles into the wood composite to improve the overall structure and the strength of the board. Okay, so as a conclusion, that one is addition of nanoparticle will increase the heat transfer during hot pressing and will help in increasing the production. So the plant can produce more, means 8 to 10%. It will reduce the amount of formaldehyde emission. We have done the test and we have found that there is a less emission of formaldehyde when we use the nanoparticles, plus it will increase the mechanical strength. And then 2 Malaysian patent and 1 US patent was granted. Okay, so I think I have covered the general one. So any question people want to ask?
Participant, if you want to ask any question, please feel free. Actually, I just want to add one thing here. In the morning, sir, Dr. DP sir has taken a lecture on the wood composite. So I want to tell the participant that that was a general introduction about the composite. Now what Arun sir is telling, it is advanced research in the wood composite. He is discussing that what are the research nowadays going on in the wood composite. See, wood composite making is now standardized. it is well known fact, well known fact that how it is been prepared. It is a well written, documented now. But what are the improvements we can do in the wood composite is discussing by the Arun sir. And one more advantage actually Arun sir is having, what he is a graduate of forestry and done MSc in wood science, so he has idea of what is wood and what is wood fiber. And an advantage, what advantage is he is having is he is working in a engineering university, and where he is applying all the engineering methods and engineering approach to solve that issues, solve that problems which is coming coming against the wood composite production. So that is why maybe since he is taking up the real issues of the wood composite, that is why he is getting so much patent. He has now total almost around 20 patents. So it is almost impossible for one person to get 20 patents in her lifetime. But he is having so much of patent in just, I think, in 20 years of his career. So that is a great achievement, sir. So I just wanted to tell the participant that it is a kind of advanced research going on in the composite. So anyone who wants to ask question, please feel free.
Okay. Another, I think one thing we need to realize.
Actually, sir, what I feel that very few person are from the forest product utilization. So those who are, I think 2-3% are from the forest product utilization. Rest all are from the silviculture and tree improvement. So those who are from the forest product utilization, they must be find it very interesting, because they know what is the advancement is going on. But for those maybe they are not picking up as it is you are describing. So yes, please carry on, sir.
I know that one. This one is a more specific and solving the technical problems. And then I think one thing that I realized, because I have done my forestry and then wood science, when we work only in forestry, the way we solve the problem is very limited. And that is one of the reasons that we are not able to solve a lot of problems. But rather than picking the forestry or wood-based product, we need to integrate all other engineering lines. Then only some new ideas will come, whether it is silviculture or growing the forest or any other field. There is a need of merging more different lines. And whatever research project we do, it is better to have the specialized people from different fields to get the ideas. and that will be useful. So for me, in not only in the nanowood composite or the other area, bioadhesive and few other things. So the main thing is I take the team, I work and I collaborate with a lot of people and then try to solve it. So I think because when I was doing forestry and other things, our scope is limited. We see only in one direction. So that was the limitation. So I think to all the researchers who are in this field or want to do it, I think better to collaborate with the universities, engineering colleges, or I think wood composite is a kind of an advanced material. It comes under the category of advanced material, whether it is a wood plastic composite or any material for any other different kind of matrix. If we merge the wood fibers with the other material, then we can develop quite a lot of new things. So it is not only for, suppose for advanced material, means even for the silviculture, we can utilize the remote sensing, latest technology, and to plan the whole area. So I think a lot of things are already available now in the market. Like earlier, we used to do the remote sensing and then find out that, okay, how we plan. So my advice to all the researchers who are here, that try to keep your brain open and then try to collaborate with whether it is institute in India or outside. We are also open to the collaboration because, as Nasir mentioned, that we have the Biocomposite Research Center. In this center, there are researchers plus PhD students. So if somebody want to collaborate, we are open. So that way, I think can try. From our side, we do have intention that I want to help all the Indian Institute or whatever way we can do it. So if you want any information from my side, we can provide to you. Okay, Nasir, any question? No questions.
Yes, sir. Yes, sir. Yes, thank you. Yes, sir. I do agree, sir, that the nowadays research is not limited to one subject only. If a person from a particular subject is only doing research in a field, his approach will not be wider. He will always be having a narrow mindset because he is having an idea of one component only. So nowadays the research is going, is interdisciplinary now. Now, if we are doing interrelated research, integrated research, then that would be, a better option. It will be always be having, better idea. So I do agree, sir. So if you guys don't have any question, then is there any question from the participant side? Actually, yes, please. Who is?
Sir, any tree material used in the industry?
Which material?
Hello,
Dr. Brijesh, yes, please. आप पूछ सकते हैं क्या पूछ रहे हैं?
Any tree material used in wood industry, sir, for fiber?
Because in suppose wood, Nasir, क्या है question क्या है?
His question is, sir, any part of the wood tree can be used can be used as a raw material for the wood fiber. Sorry, as a MDF.
Okay,
कोई भी पार्ट जो है यूज हो सकता है क्या MDF बनाने के लिए? ये क्वेश्चन है डॉक्टर ब्रिजेश.
यस सर, यस.
हाँ, जी.
ये तो मतलब कोई मेनली जो आपने वो रहता है ट्रंक है, ब्रांच है, जिसमें लकड़ी का फाइबर ज्यादा रहेगा, ये MDF में यूज हो जाएगा, क्योंकि इसको लेके अपन इसको फाइबर में कन्वर्ट, जो मशीन है उसमें फाइबर में कन्वर्ट कर देंगे और छोटे छोटे फाइबर में हो जाएंगे. तो वुड जो भी जैसे मेन ब्रांच है, साइड ब्रांच है, जिनको अपन तोड़ के फाइबर में कन्वर्ट कर सकते हैं, वो सब यूज हो जाएगा, लकड़ी वाला पार्ट. तो आजकल जैसे कि इवन अभी हमारी कल डिस्कशन हुआ था, एक यूरोप के रिसर्चर है और यूरोप में लकड़ियां नहीं है, तो लकड़ियां वहां पे नहीं है, तो वो क्या है, रिसाइकिल कर रहे हैं. जैसे अपन MDF है या सॉलिड बोर्ड है, ये है, उसको वापस लेके फिर से फाइबर में कन्वर्ट कर रहे हो, फिर से रीयूज कर रहे हैं. क्योंकि वो फॉरेस्ट को काटना नहीं चाह रहे, रीयूज कर रहे हैं। तो ऐसा हो सकता मतलब इंडिया में लेटर ऑन जो भी अपन लकड़ी फेंक देते हैं उसे फिर से रीयूज करने का टेक्नोलॉजी ला रहे हैं।
थैंक यू सर।
Actually, the sir has presented the only a part of his research. Actually, the main he is not only working on the CNT only, but he is involved with many research related to biocomposite. Like he is also working on developing a binderless fiber board. He is also working with developing wood plastic composite. He has done so much research in that also, but I think the time is limited here, so he can just present one work only. But maybe in some other day when we have if you all guys will would like to, we can request him to present his other work also. And that would be a very the wood composite, the binderless fiber board fabrication, that would be really a very interesting topic. And you guys can think of doing research in that field. It is really an emerging field, because the traditional biocomposite is now saturated. The most of the adhesive we are using, urea formaldehyde, phenol formaldehyde, that is a ban now. It is not being used in the Western countries. They say it is a carcinogenic in nature, so it is harmful, and they are trying to bypass this such synthetic adhesive. So
mechanism or to increase the heat.
Dr. KP Dwivedi.
Yeah. I have one question, sir.
Okay, sure, please.
What is mechanism which are responsible to increase the heat conductivity and mechanical strengthening through nanoparticles? What is mechanism? Why increase the heat conductivity and mechanical properties?
Yes. Suppose all the nanoparticles, mainly the one which we have used, aluminum oxide or carbon nanotubes, they are already having a high heat transfer rate. They are very good in the heat transfer plus the strength, like the multi-volt carbon nanotube. So if we check alone the material, then itself they are very good. When we mix with the wood fiber, and then it will form the layers. So heat will be transferred much faster through that.
Yeah. Okay, thank you. Dr. Arun, I am giving introduction. You know about Dr. KP Dwivedi. I am speaking Dr. Keshav Prasad Dwivedi.
Yes, I know Keshav Prasad. Yes.
No.
In GNKVV, he was my senior.
Yeah. I am happy to see in this position. My congrats for different. You have received an award. I am seeing. I am very happy for you. Okay.
So you are working where you are working?
I am working in Jawaharlal Nehru Agriculture University in Krishi Vigyan Kendra.
In Jabalpur or where?
जबलपुर में आ गया। हाँ, पहले पन्ना में था कृषि विज्ञान केंद्र में।
अपना कैमरा तो ऑन करो आप।
कैमरा ऑन करो। ओके। या
All the participants, please.
अरे तो आपने बताया नहीं है कब पहुंच गया? ये भाई नासिर हमारे सीनियर है।
नमस्कार सर, नाइस मीटिंग यू सर। नाइस मीटिंग यू सर। नाइस टू नो यू अबाउट सर।
आप लोग बड़ा अच्छा चल रहा है, प्रेजेंटेशन बहुत अच्छा मैनेज कर रहे हो। आपकी पूरी ऑर्गेनाइजिंग कमेटी को भी मैं बहुत थैंक्स बोल रहा हूँ।
थैंक यू सर, थैंक यू वेरी मच।
थैंक यू।
और मुझे बड़ी खुशी हुई जब आपने उसमें इंट्रोडक्शन दिया कि डॉक्टर अरुण आज उनका लेक्चर है, तो मैं सोचा चलो इस लेक्चर को तो आज बड़े मन से मुझे अटेंड करना ही था, और इसी बहाने चले आज वो भी हो गया, मुलाकात देखा वो काफी दिनों बाद। चलो ठीक है।
तो आपका जबलपुर में है, कहाँ पे है अभी आप?
हाँ, जबलपुर में ही हूँ, एग्रीकल्चर कॉलोनी में ही हूँ, वहीं पे F49, वो जो अपना मेडिकल वो डिस्पेंसरी था ना, उसके पीछे ही। हाँ,
मतलब लिंक नहीं हुआ कि काफी बाकी लोगों से फेसबुक में कनेक्ट है, लेकिन आपसे कनेक्ट नहीं हुए।
अच्छा
तो
चलो
चलो अच्छा है कि आप वहां पे पहुंच गए फिर से जबलपुर।
ठीक है, थैंक यू। ठीक है, अपन
तो
वो
बढ़िया है। तो
ईमेल
आप, हाँ अभी हम इसको दे देंगे और इसमें व्हाट्सएप मैसेज में भी लिख देंगे हम ईमेल आईडी और
I
फोन
will share
नंबर।
the contact. I will share the contact detail of Dr. Arun sir, and sir, I will give you the contact number of Dr. KP Dwivedi sir.
ओके
I will share it to you.
ओके ओके।
चलो बड़ा अच्छा लगा कि आपसे मिल लिए।
ठीक है, कांटेक्ट होता रहेगा।
हाँ हाँ ठीक है, अभी हम नंबर दे देंगे तो अपन आपसे मतलब सेपरेट बात कर
हाँ,
लेंगे।
बात करेंगे। ठीक ठीक ठीक।
So-
ओके ओके नाइस।
Okay, thank you. Any more question from the participant side? I think, sir, there is no more question, sir. So with this, I think we can now end up this session. And as a formal vote of thanks, sir, I would say that it was really a nice presentation. Since I was aware of your research work, so I got it almost every point, and I found it really it all recapped my memory. I revised the whole research work what you are doing there. So it was really not only interesting, but I found it very informative. So thank you very much, sir.
एक चीज और ऐड करने वाले हैं जो लोगों को पता नहीं है। नासिर ने हमारे अंडर ही पीएचडी की है और इनने बाइंडरलेस बनाया है जो अपने आप में इनोवेटिव है। Nobody earlier have done. We have extracted the lignin from the wood fibers, and that lignin we use it to make the adhesive. So we don't need to add urea formaldehyde. That project was successful, and then I continue with it. So now we are developing like a lignin plus rice starch, and that project is near for the commercialization. So we are now planning to commercialize and open the plant to commercialize it. So Nasir have done a good job during his PhD. All the findings, all the work that he have worked on the lignin. So yeah.
Thank
You have
you
done
very
quite a
much,
good
sir. Thank you, sir. It means a lot to me. One more actually information I just want to pass on to the participant that if you want anybody to do PhD to Malaysia, you can contact to Arun sir, and he is always willing to take Indian students under his supervision, because Indians are always having a multidisciplinary idea, and they have better education profile. Means their education approach is different. We have more better theoretical knowledge, so if you want to recommend someone to do PhD from Malaysia, you can approach to Arun sir, and he is always willing to take Indians under him. So you just approach him, and he is so positive, he is so humble. As you are seeing him, he is like that. He is like that. So thank you very with this word, sir, I would like to thank you very much. And if the participant will request to arrange another lecture of yours, I would request you again, sir. Please take a time. I knew that you are on a holiday and you are busy with your family, but still we spoiled your I insisted you to give the lecture, and I spoiled your holiday. So sorry for that, but thank you very much, sir. नमस्कार सर।
अच्छा, और ये हमने चैट बॉक्स में वो अपना ईमेल आईडी और फोन नंबर दे दिया है, तो द्विवेदी सर आप कर लें।
मेरे पास अच्छा आपने
ठीक
दिया है, मैं ट्रांसफर कर दूंगा, मैं ग्रुप में डाल दूंगा। एवरीवन कैन टेक योर नंबर, सर।
ओके ओके
और
ओके सर, नमस्कार सर।